Hello everyone, welcome back to another video. Have you wondered that how the save operation works for columnar database table in SAP HANA? Let's unbox this secret behind the scene with certain intriguing experiments today. But before we dive into, if you're new here, please do subscribe my channel and don't forget to hit the bell icon as you will be notified the moment I upload a new content. Also, don't forget to share your thoughts in the comment section on these experiments. So let's get started. Now, before we deep dive into the hands-on, let's spend a small time to understand the background of the challenge that what exactly this video is for. In SAP HANA, by default, when you create a table, it will be a columnar database table, not a row-based one. Because columnar is the default configuration and it offers various advantages over the row-based table. The first one is kind of a higher compression rate. What does it mean? Let's say one of the field or column you think as a name. Now, of course, in an organization, you can have lots of duplicate names, correct? Maybe the unique ID was the employee ID, but the name can be duplicate. So instead of keeping all the duplicate names, what SAP does, it actually compresses all the duplicate ones and just carry only the unique ones. So there is no such exact data loss. It tackles things with certain other index concept, but it saves a lot of spaces. And that's why I'm saying it's a higher compression rate. Next point is the indexing, because each column will behave as an index and you don't need a separate index for that. So now think about in non-HANA database table where you used to create indexes, custom indexes possibly, or maybe standard indexes. And for each index, SAP used to store a different, the content in a separate table, which was used internally. SAP manages to calculate the indexes. And that way the main table will be hit to get the actual data. So that was the overall mechanism. But by doing so, it actually consumes spaces to create those index tables, correct? Now, this kind of a space crunch can be minimized or get rid of completely in SAP HANA. So that's what the second point. The third advantages would be, of course, something mathematical aggregation. So let's say you want to calculate the sales of a region or a sales role. So you just pick that sales column and do an aggregation on top of, kind of a sum operation, and you get the data quickly, right? So, but in terms of a row based, you have to get all the rows, then you have to loop through kind of an application logic, and then you get the calculated value. So time taking and lots of processing cost. And the fourth one is, of course, the search speed. Keeping those in mind, SAP has offered columnar table as a default configuration. Now, where is the challenge? The challenge comes when you store the data, because when you're storing a data, giving all the field values to create an entry, correct? So that's the reason that time SAP cannot just think about individual column and do this operation. That time it does a different tricks and applies a different trick. That is what we are going to check today. And that it optimizes. So behind the scene, it does something as an automated way, which we don't see as a user or as a developer. So our intention should be to stop that automation by some means, so that we can see what is actually happening the moment we create a new entry in SAP HANA, what are the different memory consumption gets affected. And that will get to know what is happening actually during automation phases. Sound interesting? So let's get deeper into this with a hands-on. So let's open the HANA Database Explorer, and you can see we have different tables under the schema G093015. Let's double click on this database table. Properties, as you can see, the schema type is just now I told, table name is this, but table type is a column database table. So by default, as I said, it's a column database. So this is what the table attributes are properties. Now come to the runtime information, because this is the primary point of our discussion in this video. And you see different two kind of information, general, and the other one is the memory consumption. For the memory consumption, I will emphasize the two things called the main storage and the delta storage. And these two actually plays the key role for this saving operation or optimized way in columnar table. Let's see how this two storage actually works. If I think about this is my database table, then it will, as we have seen that we have a delta and a main section. So when we'll make a read operation on this table, both the section actually we interact eventually to get the data, retrieve the data. But while we do a save operation or write operation, it only interacts with the delta section, a delta storage section. Now this delta storage is all of a row-based type, right? And the main is the column-based kind of. So within the table, it has two different, storage capacity that is actually involved for specific operation. as a read or write. So how it actually works? So when you write some data, it goes to the delta section. Then there is some sort of a delta marching happens behind the scene in an automated fashion, which way the main section gets filled up in a fraction of a second. So that kind of a replenishing or kind of a margin happens behind the scene, which as a developer we don't know, or user as a don't know, of course, that HANA manages. But if we can stop that auto margin facilities somehow, then we probably can reflect, I can show that the moment I'm creating a new entry, it goes to this delta, and then we'll merge the data manually, then it will reflect the mean, right? And that we can get to know that how it is actually happening, what it does behind the scene, right? So let's experiment it in our HANA Database Explorer by creating a new database table, and we'll switch off this kind of a mechanism, and finally we'll understand that what are the different other mechanism which we can apply to improve this overall process, and that is called the partitioning. That will come to soon, so stay tuned. All right, to start with, I will go for this SQL console where we'll write certain coding. So what my point is, let's copy all the data from these GX employees and create a new table. Okay, so from this table we actually pick all the data which contains around 100k of records and create a new local table under the same schema. But that time how to do, we'll switch off this auto delta marching facilities, and let's see how we can do that. So I'm saying create, I can say column table, or let's check, remove the column, simply say create table, and let's see whether the default is a column or not, right? So create table, and I'm giving a new name called local employees. Now I'm selecting all the data from existing table. So let's select star, and the table name is called GX employees, right? And when I'm doing this page, it will create a new local employees table by copying all the data from GX employees, and I'm expecting that it should be a column table, though I have not mentioned it explicitly, and we'll see after executing this query what happens. But before that execution, I'll make one small tricks, that I want to switch off this auto marching concept or auto marching facilities by saying no auto march. That's all. Okay, so now if I run this query, what will happen? Let's run it. Yeah, it's successfully created. So let's open in our table, because I'm expecting now this table will be created. Let's copy and go into this table search. Voila, it's created. Let's double click on that. In the properties section, you see the table type is column. As I said, the default table type is a column table type. Okay. All right. Now the main point comes back to our runtime information. As you can see, the delta storage is showing some 100 MB, whereas my main storage is showing 0. So because I'm creating a new table by inserting the data already existing in GX employee, so it's kind of a save operation happens automatically. And as I said that during save operation, it triggers the delta section or delta storage section. So it actually hits this delta storage and occupied this kind of a space, whereas the main storage is completely 0. Main storage is not at all affected. So that we get to know during write operation, it actually affects the delta section only. So that point is proven. Also, we'll see that now the size of the table and the data content is actually 12 MB. And you see the same kind of record is copied from GX employees. Fantastic. But what does it prove now? So we'll do more experiments on that. By now march, I'll make an auto march on the same table, right? And we'll see, come back to this memory section again and see how it reflects, because now from delta to main some margin will happen, and this size and everything will come back. So next what we'll do a manual merging, and we'll see that whether the main section or storage section gets impacted or not. And if we check our GX employees quickly, you see the total size was quite less, only 2 MB, right? And main storage was actually containing the major portion of the data. Now in the local employees, you see it's a 12 MB, the quite high in size. Okay, so let's run kind of a marching operation on this table, local table, and we'll come back to this memory consumption section again to see the impacts or differences. So I'm back to the SQL console again, and let's write march delta of the table, which is our local employees. So when I'll execute this one, what will happen? The marching will happen because I'm doing a manual marching. So that way the main content will shift to the main storage location, and from there it will be persisted to the database. Okay, so let's run that. Voila, it executed. Let's go back to our local employees. I haven't yet refreshed it because you can see still the delta contents enter and main storage is 0. So if I refresh and also see the size, the table says is 12 MB, refresh it, boom. So the main content is now shift to main storage, and the size gets reduced to very less because I said it's HANA does a data compression. It's a higher rate of compression, and that reflects. Perfect. Let's write a simple insert query and see what happens to this delta march. Okay. Now let's create a new entry to this local employees database table. With the interest of time, I just prepared this query. It's simple, insert into this current schema to my table with certain fields, all the fields and different values. This is the new kind of employee ID, the maximum ID, that's the next value possible. And then I'll just go to execute this one, select this and execute. Voila. You see the message is actually worked, showing it's inserted. So go to local table, but now it is, I have not yet refreshed. So now you can see how the delta storage contents. If I refresh, what is the expectation? The delta storage is supposed to be affected now, not the main. Let's see. Voila. You see the delta storage affected, the total size of the records now get changed, but the main storage is not affected, right? So the moment we'll do a marching, then from delta to main will come back. So come back towards SQL console again, comment this code, go a little up to this uncomment and run this again. Let's see what happens. So marching performed, go back to local employees, and now you see the current state. If I refresh, back to the delta storage gets reduced and my main storage gets updated with the total sizes also gets changed. So let's quickly understand how this delta marching actually works. From the SAP documentation, it says that write operation only performed on the delta storage that you have seen. But to make a good memory consumption, optimized memory consumption and having a read performance, it must be transferred to the main storage section. And this is accomplished by the delta march operation. If you check out this below figure, you see that before march, during march and after march. Okay. So before march, the write operation performed on the delta section and it's saying the delta 1 and the main one, right? And read operation happens in both the storage section that we know already. During march operation, what happens? It actually picks the entire main storage and creates one more main, which is saying as a main 2. And the delta 2 is also for the march operation and the write phases. So you can understand during this marching phase, it basically doubles the overall table size. Okay, so it's basically very much costly, the marching facilities. And finally, what happens when the march is complete? It actually deletes the older main and delta storage, but it takes the new main 2 and delta 2. That's what happens after march operation. Now, is there a way that we can improve this bit of performance wise? Like, because I'm just picking the entire storage of main. Yeah, there is a solution for that. Looks like if you go scroll down a little below, and this is what it says just now I just described. I'll keep the URL in the video description. You can check this out. And kind of and because the entire size, the main storage plus the current size of the delta storage plus some additional memory, it actually loads. So it is important to understand that even if a column stored table is unloaded or partly loaded, the whole table is loaded into memory to perform this delta march. So that's why delta merge operation is very much expensive in that sense, because the complete main storage of all columns of the table are rewritten in memory. Okay, and complete storage are persisted to disk even if only a relatively small number of records were changed. This creates the disk I/O load. Makes sense. So this is very much kind of a problematic things that is happening. Now, this potentially negative impact on performance can be mitigated by splitting the tables. Yeah, this is kind of a solution. They're saying that if we can create a multiple partitions, right? A simple table, I'll create multiple partitions, means each partition is apparently an individual table. And we'll see. Now I'll make this local employees as a partition table. And we'll see that if I update a particular field, right, only a particular property, then obviously it doesn't need to load all the partitions, but it will only impacting the partition which contains that particular property which we are updating. Correct? So let's do that. So let's comment this code and let's write our partition code over here. So currently, if I go to my local employees and go to the partition section, I see there is no partition. If I refresh once again, I don't see any partitions. Okay. And as I said, columns are all coming under a default partition, which is 0. Okay. So now what we'll do, go back to our SQL console and create a partition. So what we'll do, we'll create 3 partitions and on top of the employee's ID. So, and we'll see that which partition holds which kind of properties. So start with alter table, local employees. Partition by, I'll be using hash concept. So employee ID based, I'm just doing the partition, and I'll create partition 3. All right. Sorry, it will be partitions 3. Fantastic. So now if I run this one, it will create 3 partitions. So let's execute and voila, hopefully, yes, it worked. But let's see, go back to our local employees and come back to partitions, refresh it. Yes, we have created 3 partitions. Perfect. And you see the different partition ID gets created and the total size, as you can see over here, it's close to same kind of a each partition occupies as a size wise. And now also it's gives the main size and the delta storage differences. So 911, 922, 912, 12 and 15, and all delta is currently 54. It's basically certain internal memory that it holds for that. The actual data content is over in the main, and it's equally kind of a partitioned, as you can see. Now go to the column section and you see that all the columns looks like apparently, how can I maximize it? Let's scroll down. As you can see, refresh, and now you can see all the columns are not in a default 0 partition, but a few columns in partition 1, few in partition 2, as you can see 2, and few in partition 3. Fantastic. So the columns and space are all separated as per partition. Now what I'll do, I will try to update now one of the record of this table. Let's say partition 3. You can do anything partition. Let's say I'll do partition 3, and let's say I'll update the employee education to something else, because when I created my record, I put my education as engineer. So this next time I'll put some other value, let's say bachelor or something, as a developer. Let's say what happens, software engineer. So, and we'll see what will be our intention now, that we are actually impacting the delta storage, but only that particular partition. One thing to be understood, that it is not possible to showcase this particular operation here, okay, because we are actually did a stop, auto merging stop, so that this kind of an before, during and after merging doesn't happen automatically. We are doing it each time manually. But now what I did, I have created a partition, and so when I update a particular record of that partition, that section I'm expecting to be updated, not other partitions. And as per the phenomenal concept that you have just learned out of this during merge operation, what happens, it actually loads whole data. So of course now it will only pick only that portion of the data which is affected, or that partition will be picked up, not entire other partitions. I cannot show you though, of course, this because this is an internal mechanism, but hopefully I understand that which partition gets affected after this update operation, and that partition will be loaded fully, and that way it will reduce down the memory kind of a consumption at the runtime during the merge operation. Right. Let's do that. We are back to our SQL console. Let's comment this code and now run update local underscore employees, and now we'll set employee education, right? So this is what we are going to update, employee underscore education, and I want to set it as, let's say, electrical engineer, and let's put where employee ID, and we set the value was this one, right? 2001 something I added. All right, so this is the code that will execute. So what I'm expecting, this my current name, employee education, should be changed from engineer to. So before we update, let's write a single query like select star, or maybe we can select like employee ID, and let's say what else, employee employee education from local employees, where employee underscore ID is equal to like that. Agreed? So what will happen if I select and execute? Let's see. So before I update, I want to see what the status. Yes, it's currently 2000 and engineer. Now once I run this one and rerun this query, it's set to software or electrical engineer. So let's do that. Now update is successful. So I have done the update, and now the expectation would be that it will impact the partition 3. Correct. Let's go to local employees, and if I go to my partitions, this delta should be impacting, not the whole. Correct. Let's refresh it. Exactly, it's only updated this partition because I picked the field which actually reset in partition 3. So when we'll do a delta merge, this particular partition will be loaded, not the whole. Right. So let's do that now. Come back to our SQL and let's run once again, just for namesake. Let's execute it and see the data. Yeah, it's updated. Of course, I didn't do any merge operation. So let's do a merge now. Let's uncheck this and do this merging. What will happen after merging? Of course, again, it will come or affect only the main storage of the partition 3. Let's run it. Oh, first of all, I have to uncheck this one, but I don't need to set any specific which partition to merge. It will take care automatically with this command or with this SQL script. So if you run, merging is done. Go back to local employees, and now if you see that the main storage is 195 and delta storage is 115, so it will be come back over here. So 915 is supposed to be increased. My bad, because we didn't create any new records. We just updated a particular field for a single record with just from engineer to electrical engineer. It actually didn't create that kind of a database changes, but the delta size gets reduced to 54, main storage as it is, no such change. But you can see the total size now gets reduced from 1051 to 985. So data compression happens, right? Perfect. So this way, when the data merging happened, it actually loaded this particular portion of the database, this particular partition only, and do this all shuffling with the different main and delta storage creation, as we have seen, main 2 and delta 2, and deleting main 1, delta 1. But the overall memory consumption is very much less because of this splitting or partitioning. So thanks for watching. If you like this content, give us a thumbs up and share it with your network, and subscribe for more SAP related content. See you next.